All right, now with this video, the focus is going to be on those problems that involve parallel and perpendicular. Parallel and perpendicular. So there was one that just wanted the slope, and then there were several near the end that wanted you to write the equation of the line fitting certain conditions. So just to remember, with parallel, the slopes are the same. The y-intercepts are different. Okay, so since slope has to do with the direction, whether the line is rising or falling and how steep it is, if you have one line like that, if the other line's parallel, it has to be just like that. They can go on forever, but they can't intersect. Perpendicular lines look like this. If you have one line like this, the other one is going to have to be at a right angle to that. Okay? All right, so this one's a little weirder. So for perpendicular, it's hard to describe. The slopes are going to be negative reciprocals is what they usually say. Negative reciprocals. Okay, so for example, if one line has a slope of 2/5, the other one would have to have a slope of negative 5/2. So if one line has a slope of 2/5, the second line would have to have it flipped over and opposite. All right, if our line had a slope of, say, -4, and you wanted a line perpendicular, it would have to be, since that's really over 1, it would have to be flipped over, and you'd want it to be positive. Okay, and then if one line has a slope of 0, the other line would have to be undefined. So those are a few examples of what it would take to be perpendicular. For parallel, it's way more straightforward. If m equals 3 on one line, then m equals 3 on the other, exactly the same. Okay? All right, so let's go ahead and look at the problems involving this. I want to back up and look at one that just had to do with finding the slope. It was number 20. And I'm going to write this out. It said, what is the slope of a line whose graph is parallel to 5x plus y equals -4? And then it asked that same question, what is the slope of a line whose graph is perpendicular to, and it was the same line. Okay. All right, and we just want the slope. We don't want you to write an equation of the line or anything, just get the slope. Okay, so what you need to do is you need to rearrange that equation. So for both of those problems, to answer either part, you'd have to take your equation, so take your 5x plus y equals -4, and find the slope by solving for y. So we're going to subtract 5x from both sides. Then we'll get y equals -5x minus 4. Okay, so these two equations are equivalent. It's just the first one is in standard form. The second one is in the form that allows us to find the slope easily, called Slope-Intercept Form. So I look at that, and I can see right there is my slope. So slope of the given line is -5. Okay, so now you want to go back and say, okay, so the given line, this line here, has m equaling -5 once you rearrange things. Okay, so this line has the m equaling -5. So on the first one, I wanted my line to be parallel. And so what is the slope of the line whose graph is parallel? Parallel, you should think same slope. So m is also -5. Okay, and you would actually just put the number -5. Okay, then on the second part, it said what's the slope of the line whose graph is perpendicular to that? you should do the same work, get the m equal 5, but you should be thinking negative reciprocals. You should think slopes are negative reciprocals. So you should think about how negative 5 is really negative 5 over 1. So you'd have to flip that over. And since this one's negative, yours would need to be positive. So you should put 1/5 for the answer. Okay. All right. So that's just getting the slope. Then near the end of the review, there's a few problems that ask you to write an equation of the line given some information. So let's look at a few of those. And they involve the words parallel or perpendicular. So here's this is number 28. It says, write an equation in slope-intercept form. Okay. That goes through the point 6,3 and is parallel to the line 3x minus y equals 5. Okay. This time we don't just care about the slope. We want the actual equation. So all of this is going to be used. That's going to be used to get the slope of your line. The line you want the equation for. Okay. So you're going to take the 3x minus y equals 5, and you're going to get the y by itself. So you're going to subtract 3x, and that means we have negative y equals negative 3x plus 5. Those are not like terms, so that's as good as it gets. And don't lose the negative. When you subtracted 3x, that just got rid of the 3x. You still have this negative right here in front of the y. It's an understood negative 1. So now you'll come in and you'll divide by negative 1. You might as well divide it, distribute it, so it goes underneath all the parts. And you wind up with your y equals positive 3, because negative divided by negative would be positive 3x minus 5. So these are equivalent, but this one is in y equals mx plus b form. So m is 3. That's all you're needing from that. So don't even let that negative 5 stick. Don't even think about it. You were doing all of this to get the slope of your line. So your line, the given line, the given line, this line has a slope of 3. Okay. Now what you're going to do is you're going to think, okay, so if that line, and by the way, don't think it's just 3 because of that. It's 3 because after I solve and get the y by itself, it's 3. Okay, if you just always take that number in front of x, you're not going to be right all the time. All right, now the lines are parallel. So that tells me my line should have the same slope as the given line. So I know m has to be 3. So now I know my slope is 3 and I have the point 6,3. So I'm ready to just write the equation of the line like I did in the earlier video. So I'm going to go get that point slope form. Then I'm going to plug in for the slope. I'm going to plug in for the y1 and for the x1. They all are positive. The formula just has some minuses in it though, doesn't it? Okay, so you'll distribute. You'll add 3. And you wind up with y equaling 3x minus 15. And that's the form they want it in. Okay, slope-intercept form, y equals 3x minus 15. So this one had some work to do. You had to get the slope of the given line. Okay, so you had to get the slope of that given line. And we did all that work, came up with the slope being 3. And then you had to think about your line being parallel. So that meant your line would have a slope of 3. And then you had this point that's supposed to pass through. So you take those two pieces and you use the point slope equation. That's a formula. The point slope formula. Pull it off the formula sheet and then plug in and finish it. Okay. All right. Let's go ahead and look at one that involves the perpendicular. So here's one. This is number 29. We want the equation again. And it says, write an equation of the line that satisfies the given conditions. Okay. All right. Unfortunately, it has it both in slope-intercept and standard form, but it turns out to be the same thing on this one. All right. So 29 gives you a point, and it gives you that your line needs to be perpendicular to, this is perpendicular to the line x equals 6. So you're going to use this to get the slope of your line. Use to get slope of your line, of the line they want. Okay. All right. So I got to think about this. It really helps to kind of think about this. If you have a line x equals 6, it just means all the x's were 6. So this line right here is going to be this line right there. This is x equals 6, the vertical line through 6. All right, now you want your line that you draw. This is the given line. That's the given line, not the line you're trying to get the equation for. You want the equation for the line that would pass through the point -8, 1, 2, 3, 4, 5, 6, 7, 8, +9. Okay, way up here. Okay, so that's the point -8, 9. So I want my line, now let's see, it said it wanted my line to be, I want my line to be perpendicular to this given line over here. Okay, perpendicular to that. So that means it would have to look like this. Okay, that's what I'm looking for. And I want to know what the equation for that line is. So you really have to do that one. You have to think about it graphically. Think about what it is you're looking for. So if I want it to pass through this point right here, be careful because it's really easy to make the mistake. Y equal -8, Y equal 9, X equal -8, X equal 9. Usually I get those answers, okay? So what about if it's horizontal like that, aren't all the Y's the same? So it's not this or this. And then would it be Y equals -8 or Y equals 9? You have to think a little bit about how all of these points have a Y coordinate of 9. Okay, that one and all the others are up there at 9. So it's this one, not that. Okay. All right, so let me do that one a little cleaner now that we talked through it. So you were given a point and you were wanting it to be perpendicular to some line, and it happened to be a special line. So your thought process should be to plot the point. Think about the point -8, 9 sitting there. Okay, actually it would look more like that. Okay, so there's your point. And then think about the line x equals 6, which would be over here. So this is your given information in blue. All right, you want the line that's perpendicular to that. So you want it to go this way. Okay, and that's a horizontal line. So when you're thinking about that, all the y coordinates on that line are 9. So you would answer the question y equals 9. Now the line parallel would be another vertical line. The line parallel would be x equals -8, but I want perpendicular, so it's going to have to go horizontal. It's going to have to be y equal 9. Okay. All right. Let me back up and do a what if. Let's do a what if on number. I'll show it to you on number 28, and then I'll quit. All right. So on 28, they said write an equation of the line in slope-intercept form that was parallel to that. Okay. Parallel. And so we wound up getting the slope, and then we were looking for something parallel. So let me move over here. So what if I wanted something that went through 6, 3, but I wanted it to be perpendicular to 3x minus y equals 5? I would still go through all that work to get slope of that line. So I'd go through all that work. I'd take the 3x minus y equal 5, and I'd solve. divide by -1, and get to here to identify the slope of the given line as 3. Then I'd think, okay, perpendicular. Okay, so if the given line has a slope of 3, then my line should be flipped over, so 1/3, and it should be negative because they have to be negative reciprocals. Then I'd go and I'd take the point the slope -1/3 together with the point 6/3, and I'd go and I'd write the equation. So you see, the only place it would differ would be after you figured out the slope of the given line, you'd have to think, well, perpendicular is the one where I need opposite reciprocals. So I'm going to plug in the 3, plug in the -1/3, and plug in the 6 to the appropriate spots. I'll distribute. That'll be -1/3 to x, and negative times negative becomes positive. That becomes +2. And then I'd add 3 everywhere. Both sides is what I meant. And I'd wind up getting y equals -1/3 x plus 5. That line would be perpendicular to the given line. Okay, so that's kind of similar to question number 30. So I just wanted to go back to the one we already did. The number 28 started with parallel, and I just did what if it was perpendicular. Okay. All right. So I hope these videos help. You can do well if you'll spend some time looking at the videos and really working the problem authentically and not just using